Hi, in this video, I want to bring your attention to a misconception that is out there related to VPNs. The fact that VPNs are secure or not. And there are different arguments about this. And I just want to share my opinion, my 2 cents on this topic. So recently, I did a post about this as well. And it caused different reactions to people. So some agree, some don't, some weren't aware of this. And so I decided to make this video just to better illustrate the point that I'm trying to make. So we're going to use this lab topology. It's a very basic lab, okay? Essentially, we have these three routers. And what I want is kind of demonstrate like this is a company. So I probably better use a different color. Let me change this. So this is one company. Let's say this is Microsoft. And here on the right, we have Apple. Okay, so both companies, they have internet access, so they connect to this ISP router using the networks 192.168.1.2 and the network 192.168.1.3. Okay, and they have their LAN networks 192.168.2.0 and network 192.168.3.0. Okay, so very basic topology. And I enabled HTTP service here on ISP router so that we can test that from these PCs. Actually, this is a PC, this is not a PC, but we can reach the ISP router, and I'm using NAT for that. So let me just show you the configuration I have done so far. So where is R2? Okay. And you can see that basically this is the interface IP. I enabled NAT on the outside and on inside of R2 and R3. And I'm using an ACL just to filter what I'm allowing, what is going to be translated in order to access the internet. Meaning that any traffic coming from network 192.168.2.0 will be translated to R2 outside interface, in this case the IP 192.168.1.2.2. so that's the IP for Microsoft router, and we can test this from PC4. So let me open here the prompt. So if I ping 192.168.1.2.1, should be successful. And because I also have HTTP enabled, I should be able to reach that as well, because I don't have any filter for at the port level, so that should be 16121. Okay, and I have HTTP enabled and the password, so I'm able to reach R1. And the same should be true for Apple in case they need to reach the internet. So let me just bring this web server. Okay, and if I ping 192.168.1.3.1, this is from web server perspective, so is able to reach the ISP router as well. So this is what you normally have at home or at your office. This is a normal network. Now we might have a requirement that we need to allow these two networks, Microsoft network and Apple, to communicate, right? There must be some level of reachability, and we could add a default route or propagate these networks into this ISP router, but we know that we can't advertise private IP address on the internet, right? That's not the way to do it. And even if we were using private IPs, even if we're using just between different services, the goal is that we don't want to advertise this network on this router. Okay, so another option would be to build a tunnel across these two routers, and without advertising this network on the ISP router. So we want to build a tunnel. Okay, let me change the color now and delete these. So we want to build a tunnel, okay, just between these two routers. Okay, so essentially we're saying that any traffic that needs to go to internet will take this path, and any traffic that needs to go to Apple from Microsoft to Apple has to go inside the tunnel in order to reach the network on Apple side. And the tunnel or a VPN meet this requirement. Okay, so we just want tunnel. We're not saying we want a secure tunnel, and I want to make this distinction. Okay, so we want to set up what is referred to as a VPN. So VPN tunnel is the same concept. Okay, and there are different types of VPNs or different types of tunnels. And essentially, we have what is referred to as pulse-based tunnel and route-based tunnel. If we take a look at here at Cisco documentation, we can see the definition of VPN. So VPN is an encrypted connection over the internet from a device to a network. The encrypted connection helps ensure sensitive data is safely transmitted. Okay, this is okay, this is true, and I want to kind of break this into pieces. So if we take a look at different types of VPNs, so here they have remote access and site to site. So remote access is when we are using an endpoint or computer to access a termination point. Let's say, for instance, we want to work remotely at our office. So in this case, we would use remote access. As a site-to-site VPN, normally it is set up between two routers, two firewalls. So we're going to set up a site-to-site VPN using route-based VPNs. With route-based VPN, we can use dynamic routing protocols such as OSPF, EIGRP, BGP inside the tunnel. As for pulse-based VPNs, we can't. Okay, that's the main difference. Obviously, there are other differences as the types of technologies, but this is one of the major differences between these two types of VPN. So we're going to set up a route-based VPN. And so let's start with R2. So Microsoft router. So where do I have Microsoft router? So I have it. So first we have to set up a tunnel, and we assign the IP address 192.168.2.3, and this will be 2, the IP for R2. And I have to say how am I going to initiate the traffic on this tunnel. So I'll say tunnel source. Let's say I'll be using my outside interface. And because this is a point-to-point tunnel, I have to set the destination. In this case will be 192.168.1.3.3. Okay, that's all we need to set up the tunnel. And on the R3 I have to do the same thing, but on the reverse side. So let me bring this here. So go to configuration mode, interface tunnel, IP address 192.168.2.3.3, and this is going to be a /24, and I want to initiate this from E00 interface. So let me type this, tunnel source E00, and tunnel destination will be 192.168. This has to be the public reachable IP from the other peer. So 192.168.1.2.2. Okay, oh, let me change here, there's a typo there. Okay, so that should be enough. Now if I look at the configurations, let's take a look. Interface tunnel. Okay, very basic configuration, and we can see that the interface is up. Okay, so if we try to reach let's say 233, this is my IP, and I'm able to reach R2 as well. So it essentially means that we have a tunnel set up between Microsoft and Apple router. Okay, we have the tunnel up, and now we have to route those networks 192.168.2.0 and 192.168.3.0 through this tunnel. Okay, so from R3 I'll say that to reach the network 120, you should use the tunnel, in this case 232, as the gateway, and I have to do the same from R2. So to get to 3 network, you should use 192.168.2.3.3. Okay, so if we go, let's say, web server, and we try to reach 192.168.2.2, is it 4? I believe it's 4. Okay, it's reachable. Okay, so we have an end-to-end communication between these networks, and we didn't advertise these networks in the service provider router. Okay, so far so good. We have a tunnel, but, and this is a big but, it's not secure. And let me show you what I mean by that. So if I bring let's bring Wireshark. Okay, so now I have Wireshark here open, and I want to show you this. Recall that we don't have any routing information at the ISP router, right? So what is yeah, that's R1. As we can see at the routing table, it doesn't know anything about network 192.168.2.0 and 3.0. Okay, and I'm capturing at one of the interfaces. Okay, and so let's send a packet from let me see, web server. I have web server to R2 to PC2, and look at this. We are able to capture this packet. We are able to see what is happening between these two endpoints. Okay, if we go to PC4, let me log into this, and let's say I want to reach I believe that's 3.5. Okay, is it 3.5? Well, let me see. It's 3.6. Okay, so let me cancel this, and now let me try again. So 192.168.3.6. Okay, so it's asking for username, so I'll type username and I'll type the password. Okay, I'm inside web server at Apple site, and look at this. The service provider is able to see everything we are exchanging. If I, let's see, TCP stream is able to capture everything we have been exchanging so far. Okay, the page, even the password. Look at this. Okay, so we do have a VPN, but it's not secure. Okay, so that's the point I'm trying to make. We have set up a VPN, and what people don't understand is a VPN is just a tunnel. It is used for segmentation. Segmentation, it means that we are using the same path, okay, to send traffic, but part of this traffic is being sent on a different path, if we can say that, in comparison with all the other traffic. So what we have so far, let me bring this. So we have a VPN tunnel between these two endpoints, okay, and we are sending our, if I want to talk to, let's say, HTTP. Okay, so this is going inside the tunnel. Okay, so this is 3.6. This is going inside the tunnel. But if I try to reach, let's say, the IP I try to reach, so let me see, HTTP, so that should be the same, actually, 8888. Okay, so 65645. So this is ISP router. Now if I'm trying to get to internet, okay, I'm not using the tunnel, I'm taking this path. Okay, so let's say that 88888, it's here. So that's what a tunnel is used for. It's just for segmentation. Okay, now if you want to make this tunnel secure, Then we have to rely on another protocol, on another technology, and that's IPsec. Okay, so IPsec is the protocol that will make this tunnel secure. And I also shared this great article from Network Lessons where they unpack how this protocol works, the different components of it. And essentially, I just want to replicate. If you want to get into the details of this, you can follow the link on video description. So essentially, we need to set up a tunnel. Okay, so actually an IPsec is going to set up two types of tunnels. They are referred to as IPsec phase 1 and IPsec phase 2. On phase 1, it is used to authenticate the peers, meaning in this case Microsoft router and Apple router. So that's what we set up the first component. So we want to validate that Microsoft is telling this, I'm Microsoft and this is my password and this is the parameters we have to agree. And some of these parameters include, so let me see, IPv1. So they have this in detail. So these parameters include hashing, authentication, Diffie-Hellman, lifetime, and encryption. This is also a great way to remember this by thinking as Haggle. Okay, so we need these components in phase 1, and when we establish phase 1, if both peers they agree, they authenticate themselves, then we'll be able to set up a second tunnel. So he goes into much more detail here. So let's see. Then once phase 1 is established, so we have first tunnel, then another tunnel is set up. Okay, this is actually the tunnel used to protect data. And we can also use the same types of protocols, okay, to secure this second tunnel, like using IPsec protocol, the type of encapsulation, encryption, authentication, lifetime, and also Diffie-Hellman. Okay, so basically we need to set up this tunnel. Okay, we have this tunnel, and inside this tunnel is like we're going to build another tunnel. Okay, and that's going to be an encrypted tunnel. Okay, so once we set up this tunnel, then the content being sent inside the tunnel won't be the service provider won't be able to read it. Okay, so let's do this real quick. So let's start with R2. Okay, so first what I need to do, so I'll start by creating crypto as I can policy stand. So this is universal, and let's see, for hashing, one thing just for notice is that when building a secure VPN, the higher the encryption algorithms, more secure it will be. But it all depends on the type of environment where you're building this tunnel. So just make sure that the one you're using, it's according to the company policies. Okay, so let's say I want to use SHA-256, and for authentication I can use pre-share or certificate. So let's just use pre-share. And for Diffie-Hellman, so let's select 14, just because we don't have to change lifetime. And for encryption, I want to use let's just use 128. Okay, so now I have to set the key. Actually, that's crypto IPsec camp key. And let's see, the key, let's say CCI65745, and address will be in this case I want Apple public IP address, so it's 192.168.133. Okay, so this is phase 1. Okay, so both routers, they have to agree in these parameters. So now let's set up phase 2. For phase 2, so that's going to be crypto IPsec transform set, and let's call it VPN. And here I have to say, okay, do I want to use AH or ESP? So I just use AS 128 as well. and I'll also use SHA-256. When we set up a tunnel, it will operate in transport mode, and we want to change it to tunnel mode. Now this is related, this is not mandatory, but it is related to the size of the packet, the header. So normally it is recommended to use tunnel mode. So the tunnel is built, and now we have to create crypto IPsec profile, and I'll name it as profile VPN, and we'll set the transform set, so we have to reference the transform set we just created. Okay, so now we're going to enable this inside the tunnel. So tunnel protection IPsec profile VPN. So now I have a secure VPN tunnel, and I have to bring this down because he will try to negotiate, and Apple router is not ready. So I'm just going to copy all of these, and let's see, bring this. Okay, let me paste this here, and I want to change this to be 1.2, and let me extend this a little bit. So that's the other thing. Okay, so interface tunnel 1, tunnel protection IPsec profile VPN, and I want shut this tunnel. Okay, and let me paste this on R3. Okay, done. Okay, IPsec camp it's up, so now let me turn this on again, and now we should see the tunnel is up and it's being encrypted. So just show crypto, let's say crypto IPsec camp SA. So this is phase 1. We can see it is established, okay, between both tunnels. And if I want to see phase 2, okay, these are the networks that will be encrypted inside the tunnel. So as you can see here at this moment, it's saying 000. So I just want to filter this. So let me get packets. So let's just pay attention to this, and you see that before the ISP was able to see the content of the packets being exchanged. So let's just get to the bottom. Okay, and let's try to send the packet again between these two endpoints. So I'll log into PC4, and let me just actually refresh the page. Okay, and it's refresh, and look at this. Now the ISP, it's not able to read the content. You can see it is encrypted. So even if I say follow, I can't, because it doesn't know if it's using TCP or UDP inside the packet. It's just saying, look, ESP is encapsulating all the traffic between these two endpoints. So only thing that the service provider knows is they directly connected IPs from Microsoft router and Apple router. Now he can't read the content because all of this is being encrypted. And look at this. If we take a look at R2, we can see that the packets are being encrypted and decrypted. Okay, so now we have a secure VPN. Okay, but we are relying on IPsec to secure the tunnel. Okay, this is the point that I was trying that I want to make. VPNs, they don't protect the tunnel by default. They are used as a segmentation, as a tunneling technology only. Okay, IPsec is the one that allows VPNs to be secure. Okay, and I hope you found this video useful, and until the next time, adios.